Okay, here we're going to look at Bohr atomic structures and how to depict and draw out what's called a Bohr model of the atom developed by Niels Bohr. Well, first off, the Bohr model, well, what is that? It's basically a simplified visual representation of an atomic structure. It assumes that electrons, represented with the E- sign here, move in fixed orbits. Each of those orbits represents an energy level around the nucleus. We see that here. Here's our nucleus. These are energy level 1, energy level 2, 3, 4, 5, and 6. Now, electrons have to exist in one energy level or the other. They cannot be in between. So again, the reason why I have the picture here of the elevator is you can only go to certain levels. You can't go to like a half level. Just like electrons can't be at level 2.5 or 2 1/4. It has to be 2 or 3, 3 or 4, 4 or 1. It has to be at the very distinctive energy levels. Now, how we'd go about drawing the Bohr model is we have some simple rules to follow. So, looking here, we want to draw the nucleus, making sure to write down the number of neutrons and protons in the center region here. After that, step 2 is going to be to look at drawing a circle or an orbit around the nucleus to represent the first energy level, as we see here. Now, energy level 1 can hold a maximum of 2 electrons. Remember, this is located closest to the nucleus. Level 2 can hold a maximum of 8, 3 is 18, 4 is 32. We're going to focus mainly on the simpler elements here so you get an understanding. After you draw that circle around the nucleus representing the first energy level, go through, and electrons should be drawn in pairs to make them easy to count, and must fill an energy level before moving to the next. So after you have 2 electrons filled up in the first energy level, then you can move to the second. After the second is full, you can move to the third, and then so on and so forth. So let's look at just a couple examples here of periodic patterns. Looking at group 1, group 14, 17, and 18. Well, group 1, see the red is representing the outermost shell of the valence electrons. In group 1, each one of these has 1 valence electron. What we do notice is that lithium here with its 3 electrons, 2 fill up the first energy level, and then 1 more it goes on the second energy level. With Na, or sodium, 2 in that first energy level, and we see 1, 2, 3, 4, 5, 6, 7, 8 in the second energy level. In that third energy level, we have 1 more, so that one is being 1 valence electron. Now, how do we know sodium has these 11 electrons? Well, we have 2 here, plus 8, which is 9, 10, 11. There's 11 protons. So in a neutral atom, there's going to be 11 electrons. The same thing goes here for fluorine, and neon, and argon. We're filling up that first energy level, progressing to the second before we can go on to the third if we have electrons remaining. So take a look at a couple of these models to develop kind of an understanding of how it is. It's relatively easy. And I want you to go through and look at some of these examples and try them for yourself. So hydrogen, phosphorus, helium, neon, and lithium. So pause the video now and try them for yourselves. I hope my students are pausing the video. I don't know if they're pausing the video or not. Hopefully they are. And okay, so hopefully you've gone through and you've taken those steps, and now we have a way to check your answers. So hopefully the answers that you came up with, that you drew out on the Bohr models, look similar to these. If they don't, go back, try to watch and understand why they don't. If not, you can always email me or ask me for questions and clarifications. But hopefully this develops a better idea of understanding the Bohr model of the atom.